Hello and welcome to the TMC Newsroom. My name is Rich Tehrani. Thank you for watching us today. We're at Interrupt 2010. It's day 2 of the show. Bill Young is with us. He's the president of HotLava. Bill, how are you?
I'm fine. Doing very well, thanks.
So tell me about HotLava.
Well, HotLava was founded 7 years ago, and we specialize in network cards that help to make servers much more productive and powerful and in a very small, constrained space. I happen to have a card with me, oddly enough. And,
Awesome.
This is an example of what we do with packaging. So we'll take standard Ethernet components, say Intel Ethernet controllers, switches and whatnot, and we pack them very tightly on a board. And so we have, in this case, 6 individual 10 gigabit Ethernet ports in one card, which saves slots, which saves space, and improves the bandwidth and port density dramatically.
So basically taking a computer and turning it into, or taking a server and just allowing it to do much more than what a traditional server could do, because you're able to add one of these cards to just offload a lot of the processing and things like that.
Yeah. Well, it's more of a packaging play, but today's modern servers are so much more powerful than it was just 6 months ago, given the new advances that AMD and Intel has made in the technology. So now we find that the bottleneck is shifted to the network I/O interface. So even if you were to have 2 gig, 10 gig interfaces, that would still not be able to keep up with the I/O bandwidth of today's modern server. So we're able to do all that and exploit the huge bandwidth capability of the PCI Express bus by packing in more ports into a single card.
So I would imagine that as servers get more virtualized as well, the I/O needs, right, we know they're going to go up per server.
Right, exactly.
And so
right,
that's
yeah.
yet another reason for your solution.
Well, right. As you virtualize a server, you're adding more users, you're getting more utilization, usage out of it, and so that puts a greater demand on your network I/O. And maybe you want to do that in a smaller package, maybe a 1U or 2U, as opposed to a 4U. And so we get more work done out of a smaller space.
Are there any people taking open source router software programs, putting them on a computer, and then building super powerful routers that are kind of like an open router, as opposed to going to one of the vendors in the market to buy, like let's say a Cisco?
That's a very very good question. We have plenty of customers that do that. It happens to be a customer that or a company that, by the name of Viata that takes a Dell chassis today, plugs in our cards, and does maybe something between 85 to 90% of what a Cisco router does today at a far lower cost. So yes.
Well, it makes good sense, right? You've got these really powerful Linux software packages, right, and you've got Moore's Law, which is affecting the Intel processors faster than other products in the market, or at least Intel computers. It seems like it is anyway, where you've got multi-core design or multi-core chips that you're putting into these boxes running at super high speeds, and you're able to leverage something like this to just make it a fixed function device as opposed to just a generic server.
Exactly. And that development curve is continued to accelerate with, in this case, Intel's announcement of their next gen processor with what is that, a 33% increase in the number of processors, increase in the memory bus bandwidth. Exactly, and so we're pushing more packets, we're pushing more data through the systems in a very small space constrained server.
And how many of these cards could you put in a machine before the PCI Express bus starts to choke?
Yeah, well, it's not so much the number of cards, it's the number of active sessions. One card in today's server could probably push it to the bus to its limit. We have a by 16. We have a by 16 configuration, which is, I should say, by 16 lane configuration, which is the maximum of bandwidth you can get in today's server. We also offer them in by 8 lane versions to fit what legacy servers or what slots are available you might have. But at some point, it's beyond just bandwidth because it becomes port connectivity or port density is also oftentimes equally important. You might need a couple of ports of data. You might need a couple of ports for high availability, or maybe another couple of ports for backup or redundancy. We were just talking to some attendees here today, and they want fast, high-speed access to the disk server, but they're not quite ready to invest in a very expensive 10G switch. Maybe pop in a couple of these cards, and you can have 6, 12, or 18 servers directly attached to your disk server.
Oh, right.
Yeah,
okay.
yeah.
So there's a lot of different things you can do with this card. I mean, if you just think about it.
Yeah.
A little bit. I mean, I see an application in high-end video transcoding as well.
Yeah.
This is another place where...
Right. You're working with raw video, and each user can have 10 gigabits access to the server simultaneously, up to the point where the server saturates. But that's going to happen perhaps during peak periods, but not all too frequently, perhaps. Right.
So what's next for the company?
Well, we've been riding the technology wave, the Ethernet technology wave, for the past seven years. We started out with 6-port 10-100 NICs, and then 6-port 1 gigabit NICs. 10G NICs today was where 1G NICs were, 4 or 5 years ago, and we see 40 and 100G, not in the not too far distant future. Maybe with adequate cooling, one hopes.
Yeah, well, I'm sure we'll have new cooling technologies, whatever, the refrigerator on a chip. Maybe that's a good product for you.
There we go. You said it here first.
So thanks for being on the program
Well,
in the newsroom here, and have a good show, right?
Appreciate it. All right.